want to address a small example now of bearing monitoring, just to see all those components in action. So we have this system, which is a motor and a gearbox, and has some sensors on it, and we are using this measurement unit that we've seen before. And we will now connect to the measurement unit and see how the setup is done for the bearing monitoring. So let's go here, this one. So in channel setup, as I already showed you, we are acquiring the data with 40 kilosamples per second. And what we do then, so we first of all do the envelope detection. This is a MAT module, so it's this one. So we do envelope extraction in time domain of the acceleration signal. So we get directly 40 kilosamples in, and we get out the envelope signal, which basically filters the low frequency noise and only focuses on these peaks, on the spikes in time signal. Of the spikes have a high frequency, and then you want to see how fast these spikes actually repeat themselves, and that's how you get the bearing frequencies. So this is the setup of the envelope, and then we also do the order tracking of the envelope. So because we want to have the data actually normalized to the RPM. If it changes, we want it to stay always the same. If the RPM changes, we want to have the same looking FFT. That's why we use the order tracking. So we have the envelope signals, as you can see, as the inputs to the order tracking module. And we are focusing, of course, on the order waterfall versus time. So we will have time updates of the order waterfall, basically. And we have the key phaser channel. So we have a digital input that measures pulses from a tachometer from the motor, as this is our phase reference, actually our RPM reference. And then we are also again averaging this order tracking that comes out. So right here we have another average, so that we are averaging order tracking over 1 minute. So each 1 minute another order tracking FFT comes out of the system. So this is how it's set up. So the order tracking as an input, and then averaging 60 seconds. And this means that we now finally enable this order tracking average in the OPC UA server. It's this one here. Basically those channels. Of course, we're also monitoring the normal vibration velocity, but let's focus now on the envelope signals. And we go back to measure mode here, and we go to our web client that we haven't yet touched. So this is our web client, in fact, and we are monitoring this bearing here, schematically shown, and this is the envelope. But now let's look into the details of this bearing. So we have separate amplitudes of each of the bearing signatures for each component. So how do we do that? If you remember, looking at our report here, we have 4 characteristic lines in the FFT, which is this one, 97. It represents the the outer race of the bearing, and then we have the 127, 157. So they are the inner race, the outer race, and the cage. And we can see that the outer race vibration is the highest. So we need to look at this especially carefully. And now we will plot the amplitude of each of those points over time to see if it's increasing and decreasing. So this is the web client, and we are plotting each of the amplitudes. As you can see, this is the outer race amplitude, this is the inner race amplitude, this is the cage, and this is the rolling element. The scales are all the same, so we can see that the outer race is the highest, but also we can see that it is actually slowly growing. So if I move this away a bit, like this, you can see, let's zoom in into here. The orange line is just a reference. The orange line is the RMS vibration velocity. So this is what we get directly from the accelerometer, almost without any fancy mathematics. And you can see that it's just constant, more or less. But looking at this outer race amplitude, it's slowly growing. So over the last 2 months, this is from 22nd of January, as we are running this system, it's slowly increasing. And the others, the other parameters are not really increasing. So this gives us some indication that the outer race of the bearing might slowly get damaged. So we will look now through time to this trend. And if it happens to go up a lot, this can trigger some alarms, and it will be interesting to see that in future. So I can also show how this setup is done in the web client, so that you get a feeling for that. Some of you have already created really nice dashboards in Grafana, so know how to work with it already. We basically need to set up the queries to the database, and here we need to choose the basically the name of the channel in the database, which is this ENVOTAI average. So this is average of the envelope over tracking for the AI1 channel. And then in this case, we want to address the 98 line of the FFT. So we put this in and then name it, and then do some more configuration on the visualization part. So we can choose the scaling of the y-axis and so on. And that's also all, of course, explained in the manual. But if you want to access only one point of the FFT, for example, in the Grafana, you need to address it here, for example, under the field, and instead of the star, you need to put in the name of this line. And these are some tricks that you can use in Grafana to get a lot of meaningful data out. Of course, I mean, the aim of the monitoring application team is to help you with that, or even to create these applications for the end user. So depending on the project, as you already know, we try to discuss which approach makes the most sense.